Hello, everyone. My name is Vladimir Spreitzer. I'm today your mentor on Data Engineering Camp. We will speak today about optimization techniques. Well, mostly, I think not only optimization techniques, but more on common mistakes that young developers or database developers can do while working on queries. That's how we avoid some complex things in performance, some performance issues, data quality, and so on. I think this would be useful for you. Let's start from the temp tables, temporary tables. Like how many of you knows the difference between the tables that are created by using @, number sign, and double number sign? These actually temporary tables are mostly like commonly used when you want to like improve performance. You collect a sampled set of data that can be used through several subqueries and so on, and this is how they are minimizing the read operations on database. Well, yeah, let's start from @sign table, like it's in memory, called in memory temporary table. All the data that is inserted into this table is actually stored in memory, and that's why the query to this table, like subquery to this table, is pretty fast. So the syntax of creating such a table you can see on my screen. The second one is also temporary table. The difference between the first one is that all the data actually stored on hard drive. Like database is creating a local table as usual table, but not on the database you are using, but it's in its own system databases called tempdb. And the third one, like with two number signs, is actually the same table that is stored in memory. The difference between them are that access to this table you can have just from this session, and access to this table you can have from different session, like it's global things. So let's take a look on them. Like let's create and try to select some values from there. Hey. Yeah, this is the query. If I will want once again to run the query here, it would give me exception. Yeah. So if you want to have multiple results from this kind of query, it should run into a single run, just because after the command will finish, the memory would be released, and all the data that were stored in the memory will be empty. So you won't be able to access once again to this kind of table. So this way we receive two results, but if we want to select to execute another command, we will have an exception. These tables that are stored into the disk are working a little bit different. So when we created a table, so as far as the data is written to the disk, we can have access to the data whenever we want for the table with single number sign, we can access just from this session that is created. If we will open another session, we won't have access there. That's the only difference between the tables with two number signs. So here I receive results. If I will add another number sign, I will receive results in separate session as well. If we will take a look and open the temporary tables in TempDB, like it's databases, system databases, TempDB, we will see here the tables that we just created in here. And when we will drop them, they just emptied. As a general use, in-memory tables are best for the result sets that are about 1,000 records. It just depends on the amount of columns of the result set, just because like they take more or less memory. But like as general use, if you want to use temporary table in order to have some result set that can be reused in later queries, subqueries, and so on, it's better to use a memory table with the records limited to 1,000. Yeah, depending on situation, as I said, as on the number of columns, on the type of columns, but as a general rule. Temp tables that are written to the disks can be used in all other queries. If you want to use them in just single session, you use with single number sign. If you want to use in separate, like in a separate session, or might be in several sessions, and have access to the data from there, you should use temp table with two number signs. One great thing on them that on these temporary tables, they are actually the same tables as usual ones. You can create indexes in order to speed up the join operations, and it would increase the performance. Yeah, that's all for you. Regarding the temporary tables that I used, and we will go to something that is better known to you. I think using not and not in operands and nulls. When it is useful to use not in, let's have an example. You want to select from one table the rows that are missing in the other. So for that, we will create a temporary table, insert the two values. In the other table, we will insert just one value. And well, let's write not in. Yeah, you will receive just the value 2 that is missing in the second table. That's pretty clear for everyone, but these kind of things, how do you think will work with this kind if I will insert another null value into the table? Yeah, that's a tricky question, was just because it has a little bit slightly different behavior. We won't receive any value. That's a trick while working with not in and the column that accepts null values. So how can it be rewrite? So or we should somehow point here that we want to select everything without nulls. So then we once again receive the result, or use except statement. Select from table 1, except select from table 2. Yeah, it would give us exactly the same results without not specifying is not null filter to the second table. One thing to this except statement is that the column names and the order of the columns should be exactly the same in the first table and in the second table in order to this query to be able to run. In all other cases, it would give you exceptions. So yeah, actually in works slightly different. So we will write from Q1 and remove this query. So in this case, we will have some results. That's just because not in and in works slightly different than SQL Server. So keep in mind when using not in with within your queries with the columns that accepts null values inside. Another great thing is, well, pretty often mistakes junior developers or the guys who just start working with the SQL is working with the date formats just because it's the most popular close to it, because we want to take some information for some period, for a day, for a year might be. So we know that there exist a lot of date formats. So each date could be written in different ways. But as we can see, they even are interpreted in a little bit different way. So here we do have month 5, and here we do have month 12. But as we take a look on the dates, so we would expect that in every date we would have just December. This kind of things also depends on the server on which your queries run. So let's take a look at the exact same values. Yeah. And what we see a different result. So for sure, it's not what we expected. Yeah, you can compare like first column, first value, second value, third one, and fourth one. So what conclusion can we make from it? Well, let's not use some of the date formats. Yeah. Yes, that's right. Let's, for example, check another things that could be within working with the dates. Like let's, for example, insert the value in the temporary table. Yeah, and it worked. Let's change a little bit date format of the server, and we can see that we got an exception just because the well, it processes the date slightly different. So might be when your script will go to another server with different settings regarding the dates, formats, regions, and so on. So your code that was working fine on your like laptop, PC, on your local server could break all the stuff on the production server. So keep in mind all these things. Also, it depends pretty much on the language of the server that is selected. So you can see that exactly the same dates in English could be interpreted like they are interpreted exactly the same way. So if we will change the language to German, so we will see that, well, actually we get another results. So conclusion is like, okay, let's not use first two date formats just because they are giving us different results depending on the language that is selected, and let's use the rest of date formats. Yeah, but when we change to another language, so we get another exception. So yeah, everything depends on the settings of a server where your query is running. To avoid such exceptions, it's better to use the last one format. It's also called ISO format. That is pretty familiar to you, where first 4 digits are years, second 2 are month, and the last one are days. So in that case, all the dates that are used inside your queries to limit the query output would give you like this, the exact same results, and they would work on different servers. Yeah, now let's take a look on the dates further, just because we can get much more interesting things by using dates in our life. How is better to filter the data? Like we do have our school database with DBO person table, where we do have actually enrollment date column. Yeah. If we will write the query that would count us the number of persons that were enrolled at this date, so it will give us results. So everything seems fine until we will see that actually the column enrollment date accepts date time values. So if we will store not only the date, but actually the hours and minutes when the person was enrolled to the course, and we will run exactly the same query, it won't give us the result just because like the dates with hours and minutes are not equal to the exact date. So in order to somehow handle such situation, developers start inventing queries somehow. Like everyone knows about character functions, converting things. So and they start writing kind of queries like this, like convert to a string that would limit the date to 8 characters, and this way the information about hours minutes would be excluded. So you will once again get the results, or it could be casted to the date things. All of these examples actually are bad examples of how should we deal with the information in the table. It's just because it makes some calculations on the on every value in the in our select statement. So it takes a lot of computation, things like CPU, memory, in order to convert or make a calculation from the values that are stored inside. So better not to use any mathematics, any casts, any conversions on the source columns that are stored into the table. So that's why we need to give a range to our query. So let's say like the starting and the ending of the day. It can be run by using between, and it can be run by using greater than and less or equal, or even just simple less the values by pointing out exact the same, like end of the day, hours, minutes, and seconds. Yeah. But these kind of queries, if we don't understand like the data types, would give us sometimes a bad results. Why? Because datetime is more precise data type. It stores milliseconds, and when your value falls into the range between 23:59:59 to 24 till the midnight, this row won't be returned. So, or we need to, in this case, we need to add milliseconds on our query, just because like between is equal to the, like it takes all the range, start range and end range is, it compares like equal, like not greater than or less than. So we, in this case, by using between, we should add milliseconds into the end date, or when the same goes to greater than and less than statement, or we can adjust the date and a day to the date and put less operator. In this case, everything would work fine and we will get exactly the same results. That's what is related to the date. Sometimes we need to get results for a time period, like for a month, for a year. And yeah, there is a lot of ways to invent a query or how we can receive the dates. Yeah, we can write a like statement in order to like compare just the year and months of the date. We can use date part function in order to get the year and the date from the date time value stored in database and compare to the month that we want to acquire. So yeah, this is another way of converting this value into the year and month. Same goes with end of month function that would give us the last month of current month, and then we would be able to compare it to the value. So as it was said before, let's not use any calculations, any conversions on the source column, because it takes a lot of computations, a lot of resources of the server in order to convert the value that is stored into the table with the value that we want to compare to. Yeah, how to write it? Yeah, let's also give a range and count the value. So in this case, it would like will improve the performance. It cannot, like, these kind of things might be not visible in small database like school, just because there are not much records inside, but in greater databases like with million of rows, so it's very significant to use these kind of conditions. What else could be done in order to do that? We can make some kind of calculated columns that would store the end of months. Like in this case, we will have another column that would store end of month for each date, and the comparison with it would be working pretty fast, as well as indexing of this column that would improve the performance and speed up the query. Yeah, that's what's related to the date. Another thing with explicit conversions, all we know that we can convert some values while working as it was done with dates, like this string value is converted to datetime, to date value, like depending on what we selected on the left side. Explicit conversion, we can actually have much more performance issue if we want to write the query in right form. For this, I used another database, AdventureWorks, and the table employees. It has much more values inside. Yeah, and even on this table, we can see the difference in performance. So in the first query, we will compare it to the integer value, and in the second query, we will compare it to the like string value. Let's take a look at the table types of what is stored there. Human resources, employee, and we will see that actually national ID number is stored into the string. And we do have an index there. So let's see how it works. Let's include our query plan. Yeah, and we will see that actually we do have here some first one, like we will see a small triangle with the yellow color that would say us, hey, we do have conversion issue, like not an issue, but warning that it's converting actually this int number to the string, and it computes more resources comparing to the second query. Also, we can see that actually it scans all the tables in order to do such to receive such results. And yeah, like we will compare the number of records read, like we will see that here is actually yeah, here is actually we read all the rows from the table, and here we read just one single table, just because the index was used and no conversion things, implicit conversion things were applied to the query. Yeah, same goes with like statements. So let's switch back to the school, but yeah, probably we won't see here such performance. Like, let's create an index on a string. Yeah, we've set up a French language and we don't understand what exception it's writing to us. At least someone of you knows French. Yeah, index already exists. On these kind of queries, by using like, yeah, we see that actually scanning of the table is performed. And on the last one, indexing actually by using index that we just created is done. Like, why it's made? Just because, as I said before, we are using some calculations, some conversion things on the source column that is stored in database. And in these kind of things, optimizer can understand pretty good, like what should he use, like should he use an index that is created on the table or not use the index that it was created. If we will take a look on the adventure works, where we do have more data and run exactly the same, like exactly the same queries with exactly the same function substring left and comparing to some values, we will be able to see the difference between the number of rows that actually are read in tables. So yeah, it's significant difference. So in the last one, where we don't use any conversion, any operation above the column, index is used, and actually just for rows from the total amount is read. Yeah, as I said before, don't try to avoid any calculations on the very close on the columns of the table. Mathematics, another topic. Will we get the same results? Well, actually, no. It's just because of the same explicit conversion. So these two values are interpreted as integer values, and the results of the query is also being as integer, and we won't receive any digits after 0 point. So in order to do that, or we need to use decimals to receive or make some conversions like these kind of things. To evaluate in order to receive exactly the same results. So yeah, when dividing, working with mathematics that are on integer columns, take a look and try to understand what results are you expecting to receive. If there are some kind of dividing operations in your formulas met, so yeah, do the conversion things of the column in order to have the results more precisely, just because if you will receive two different values, you will in the end receive incorrect values. I think about collations you had already discussion in the first sessions of data engineering camp. Collation is about the language, the way how it is working with the text information. Like, is it accepting Unicode values or like Latin, or might be like Russian symbols and so on. Does it understands that text is case sensitive or case insensitive. So, and it actually, well, depends on collation on the database. We will be able to receive different kind of results. Like, as an interesting example of this, let's take a look at this sample. It's what we will receive from this query. Is A equal to B? Well, obviously not, and we shouldn't receive anything. But if we will write a query, we will receive the results, just because our current collation doesn't understand what our Russian symbols is and convert to the like question symbol, but both question symbols are equal. So, as I said, it depends on the collation of the database. So, and we will create a database with the different collations to ours and write the query. Yeah, we will receive the behavior that we were expecting, that these two characters are not equal. So yeah, we need to check when we are working with these scripts with text comparison of the texts, text values. We should keep in mind that collations between the database, data source, or destination table, database could be different. And if we will move our code to another servers, we will receive another. We will be able to receive another result. Yeah, as an example of collation, let's change the collation, and it's case sensitive. Yeah, it's case insensitive. So when we will compare to text values, it would say us, yeah, actually this text value is equal to this text value. If we will change the collation of database to case sensitive, yeah, we will receive not the result as we expected, just because, well, usually databases are created with case sensitive collations. And we should keep in mind when we writing and comparing, and when we are expecting to receive some values from the, might be it would be a code of some dictionary. So yeah, we should understand if database accepts this kind of case sensitivity or case insensitivity, and like write exact the value that we want to compare. Yeah, another thing is working with isNull and colis. Do you know what these comments are? So we are checking on the value on null value, and if it's null, like writing something. So let's take a look on the behavior of these comments. Well, actually, we expect to receive exactly the same like text from colis and from isNull, but nope. Yeah. The difference is just because of behavior of how this operates works. As I said, there are kind of implicit conversions in the server, and when isNull operation is working, it converts the value null to the data type of the A value. So that's why the string is trimmed, shorted out, and returned to the N value. Same for the null string. So colis works like differently. It converts to the right part of the result of the parameter. So A actually will be converted to character 4, and this is why we receive null, like fully written. Yep, same works with the integer values. So we declared I as integer, and this decimal value will be converted to int, and we will receive without point. On colis, we will receive what we needed. So yeah, keep in mind that isNull is converting the values to the left parameter. Colis is converting values to the right parameter data type. Yeah, next thing is views. There are also could be a lot of issues with views, just because they are created in order to speed up the let's say navigation through database, combining the tables, combining the fields, like not to not to write all the joins every time we need to get some data. Views are created, the joins are made inside, and so on. So yeah, let's create a view and take a look on the behavior. Like we create Well, actually, we do have a view. Let's drop it and recreate once again. Just a single single join. Simple, we return on all the fields from the tables. And well, actually, yeah, as you can see, the results are in place. If we will create on the person table another column like birth date of a person, what would we expect? We would expect that automatically we would receive the column into this view, but actually that's not true. We should recompile the view in order to this change to be taken in place. Yeah, and that is also one of the reasons why we should avoid writing select star in all our queries. Like, for example, yeah, as we already know that we created a table birth date, but actually after we created a table, we recompiled the view in order to receive this column. But actually after that, we understand that, hey, we don't have any information for birth date column, and we drop then this column from a table, and in the end we got an exception just because the view waits from us that the column birth date would exist in the person table. Yeah, we need to recompile once again the view in order to receive the results. So how to avoid it? As I said, we should write all the columns, and before dropping some columns, some items from the table, we should check the dependencies, how it's done. Like if we will right click on the table, we have view dependencies. Yeah, we will see that we have a view that is referencing on this table, and we should open manually the things, the view, see if the column is used or not, and after that, like, change the view, drop the column, and everything would work fine. One more interesting thing with the views is also query plan. So if I'm querying the view, actually we can see that both tables is using student grade and persons. But let's say what would happen if I would like to receive just the information from persons table, like last name and like first name. Yeah. Oh no, it didn't work that way. But yeah, it's example. Yeah, here in this example, we also are reading both tables, but actually it is not working always that way. Let me try to to check if might be I will be able to receive this behavior that I'm expecting. Yeah. See now, if I will query just the value from the table, the column that is belong to the student grade, the second table is not using. It's just because sometimes optimizer understands that actually we don't use um, to read the all the tables that are stated in the select statement. So, and that's how he eliminates the table from the query. There is some time with the left joins. It could be we can get this kind of results when we will query the column that is belonging to the person table. No, I can't receive this kind of things. Yeah. So won't be able to show you this with the left join with the person, but yeah, sometimes optimizer can understand that actually he can avoid using the student grade and show just the person's. It also depends on the keys, on the relations between the tables. Yeah, if we will take a look at the bigger views, actually, which we have in AdventureWorks database. Well, let's say when we are querying the table, like we are expecting also that we will join and take just one tables, and we subquery just two tables. And when we will take a look at the query plans, actually we will understand that having exactly the same results from the view and from the table, we receive exactly the same results, but like from the performance point of view, from the number of reads to the database, from the number of tables that are queried, yeah, we will be able to gain much improvement when we will rewrite or write our own query, and by using only the desired columns, desired tables. Yeah, some that's when we will work on the with views and so on. So yeah, let's take a look. It's worth taking a look on the execution plans in order to understand like how it is used. If optimizer understands that we want to take just few columns from few tables and so on. Well, we almost come to the end. I just wanted to show you some additional things. When working with strings, yeah. When we will select and try to find the length of these kind of strings with the spaces at the end, well, actually, we would try to like expect him to give us a result of 4 symbols, and 1, 2, 3, 4. Well, we would expect 8. Yeah, but we receive 4. Actually, when working with strings like calculations, comparisons with the strings, like SQL trims the string, and when we will store the results into the database, so we will receive not exactly the actual information regarding the characters number that are stored there. Like same with null if, just trims the value, understands that text is actually with the space at the end is equal to the text and returns us null. And when comparing when we are doing comparison, so it also understands that, well, text with the spaces at the end is the space is is the same text as text without spaces. So what we do, like we should control behavior of how the data is copied to the database. We should somehow trim, mark, or like create some operations, run some commands that would trim the values and like not store the text with the spaces if it's not intended. And when we will do comparison, we also should keep in mind on this kind of behavior of string values. Yeah, I think that's all from me for today's webinar. And yeah, that's all. Thank you for being with us today. Hope it was interesting, not too boring. Yeah, thank you once again. Bye.